Is it okay now? Can somebody confirm to me?
Yes, sir. It's clear.
Okay, because no, I'm on depending on hotspot because I'm out
Yes,
of
sir.
station. That too, it is a Zoom. Okay, and we don't use Zoom, so there is a restricted network. So for the benefit of the bandwidth, I'll switch off the video,
Yes, sir.
and you
Yes,
just
sir.
indicate to me. I start the presentation.
No problem, sir. No problem.
Okay.
So we'll just then begin then. We are making it YouTube live. So start.
Good afternoon, everyone. Today, we at Ashoka Universal School feel truly honored and excited because we are about to interact with a personality who has not only reached for the stars but has also brought the space science closer to all of us. Let me introduce to you a visionary leader, a true nation builder, and an inspiring mind, Mr. Sudhir Kumar N. Mr. Kumar is a mechanical engineer and an industrial engineer by qualification. But beyond that, he is a passionate innovator who has dedicated over 2 decades of his life to ISRO, India's pride in space research. From being a core team member in creating Asia's largest solid rocket propellant plant at Sriharikota to overseeing vehicle assembly building projects and the GSLV MK3 facilities, his work has literally powered India's rockets to the skies. He has also represented India at the International Space University in Austria and later served as the director at ISRO headquarters and the public relations officer of ISRO. What makes him truly inspiring is not just his role in critical projects, but his commitment to capacity building, technology transfer, research collaborations, and outreach programs, ensuring that the torch of knowledge is passed on to the next generation. Dear students, today we have with us a man who has not been at the heart of India's space journey, someone who proves that with vision, education, and teamwork and dedication, even the sky is not the limit. With our esteemed guests, we have our advisory members with us. Apurva ma'am, who is a NASA space educator, Girish sir, who is a renowned astronomer, and Jayant sir, who is a former ISRO director. And all our school heads, we welcome you all. So let us welcome with great excitement and big round of applause Mr. Sudhir Kumaran.
Over to
Thank
you, sir.
you.
Now.
Thank you. Thank you. Yeah. Thank you. Hope I am audible.
Yes, sir.
Very nice of you. Very nice of you getting connected. And very thanks for interacting with the kids. Being it's my passionate, let's say, journey. Even though it is rescheduled, I'm very apologetic for rescheduling because I was just landing onto the flight to move to Coimbatore from Chennai. I'm very happy to interact with you people. And first of all, Nashik is the place, is both historical and spiritual. Okay, one side it took the traces of Lord Rama, and another side Lord Shiva, and another side Gupta Godavari. I think near that one is the Gupta Godavari. Okay, and Panchavati is all you are in a so kind of pious region which are dated to Ramayana. Okay, and before that one, I do not know how many thousands of years beyond our imagination. Such a beautiful place you are, and I am sure the kids also blessed with the same kind of DNA Lord and thanks a lot again. Because we are celebrating this week, probably next week I should when we had fruitful sessions with uh, various space leaders. Subhanshu has gone up and safely came back, and it become one of the important milestones for us in the recent past, weeks before. We were at the cognitive astronaut after all decades. We had an opportunity to see one astronaut, and one Gaganyaan program is going on, and we are celebrating this second international space day, the event of landing our own spacecraft the in the successful attempt near the South Pole, when many space nations are rather but could not, I should, I should say, succeed. So, with that initial note, I am just switching over to a presentation so that when I am talking, you will get connected. And just to me that presentation. So I have chosen this page 2 because so far the space has been a conventional, an orthodoxy, an organic, because only very spaces is what we're doing. When once lots of activities are happening around the world, lots of activities. Why space has become a discussion, a specific discussion? Economic wars are happening. You are seeing every day when you switch on the news. Same thing. This fellow has become something like that. Protecting sovereignties. Very several, right from Iraq war, Iran war, then your Israel war. What for the wars are? Again, getting the supremacy on the, and acquiring the access for their comforts and acquiring the energy for their sustained comforts, leaving the other people. All these things, what is common, and in addition, this kind of, let us say, wars for the energy resources, the entire globe is suffering from so many social problems. Out of nature, out of created problems like urbanization. Villages are becoming empty. Then cities are becoming overcrowded because of the is not there in many cities. The traffic is a nuisance. Pollution is a nuisance. Then on the other hand, we have forestation because of natural fires for commercial activities, Forests are getting killed because of what happens, the imbalance in the atmosphere, the carbon imbalance. There are no proper forestation because of timely rains will not come. Ecological imbalance is coming because the drought is coming, which is famine is coming. One side you have cyclones and floods, on the other hand, drought. So global warming is going up day by day. Glaciers are melting. When the glaciers are there, we will be assured for the continuous drinking water. When the glaciers are melted, what happens? The sea levels are rising. The rivers are depleting. All the natural problems are one after the other is keep coming, and every day, if you see, not an exaggeration scale, every day these problems are increasing. Probably our generations will go away. Your generations, you should always think that how these problems are affecting your life. Tomorrow, if global warming is there, every room, even in living rooms, you have to put AC. For that one, money is required, power is required. You don't have power, what do you do? Children, I'm telling you, you should aware of these problems, and you are the people who fight for yourself. How? How the technologies? The technologies to conserve space. Space has been identified as one catalyst or a tool to identify all these let's say sustainable measures or depletions or scarcities. If you take water, water is getting depleted. Going away because you are plundering the water on the name of agriculture, unwanted agriculture. How you can find soil moisture, exactly you can operate your rivers, dams, gates exactly as per the water requirement. Today, if you go to villages, what happens? Entire fields are flooded with water. Whether that much water is required? No, it's not required. It is because most of the 80% of the water will be evaporated. But if the 80% of the water is there for the down the line people, their crops will grow. So there, the space technology, remote sensing is coming to picture to identify what is the moisture level that is there, and how much water is required. You can operate in countries like very advanced countries like Israel, such kind of countries where water is scarce and they are water. Sluice gates, their dam gates are operated by IoT sensors and the technologies. See, you cannot, uh, you cannot control the pollution. You can control the causes of pollution using the space. When is having huge amount of pollution because of uh, some agricultural fires in the Haryana that adjacent areas. Now the Delhi government has put a watch on when and how these farmers are firing the crops. Then they have used the satellite pictures. Believe me, they have come to several. They have identified in which time the fires are happening, so that the penalties will be put and controls will happen. Now these farmers gone
Excuse me, sir.
to next
Sudhir, sir. Your
level.
voice is breaking, sir, again. It's
They
not audible.
know when the satellite is being passed. So during that time, they don't apply, they don't fire. Rest of the time, they start. Another plan to acquire lots of data to control it. Again, groundwater resources, you have ground penetration radar to find out where the water is available, so that when you put a bore, you will get the water, the assured water. Similarly, so many things. If I start telling like that, smart cities. In the smart cities, your gas pipeline erection, drainage, underground drainage erection, or drinking water supply, everything is being mapped under umbrella scheme using satellite imagery. So if you start this technology being used, almost all the morning it is application, banking, training, Zomato control, their tracking, car is growing, how everything the satellite. So it's not your responsibility to understand. It will help you in your real life and get to know that Dilip, is it okay?
Hello. Yes, sir.
Okay, fine. So what I have done, I have just getting connected through my mobile. I will show the slides in the PC. I will talk through mobile.
Yes, sir. Just slide echo is there. You can turn one
Yeah, yeah,
mic
yeah.
off. Sudhir, sir, you are saying something?
Even a small variation that all. Yeah. Can I? No. Can I continue?
Yes, sir. You can continue, sir. You're audible now.
Okay, fine. So that's what I was telling the optical imaging. What happens? That's what I was telling the optical imaging. What happens? It has got multiple colors, and these multiple colors we can use on and based on body spectrum. And that is some of the times when optical images or optical cameras are going through the clouds, you can't penetrate the optical images through the cloud. There is a technology SAR, synthetic aperture radar. If you remember recently, we have launched one NISAR. In that NISAR, this is the synthetic aperture which we have launched. Okay. And the satellite technology is used for the digital twins, the building information system, where the number of the towers and other things they can. Some echo, suppressing the echo. I don't know. So just give me 1 minute. I'll.
Yes, sir.
Yeah. The satellite technology is also used for digital twins because, see, you just imagine there are, if you just go to the cities like Bombay, Bangalore, Calcutta, huge number of towers and buildings are available. Let's say Infosys building or like the business towers. How much energy that is required to operate that building? Huge amount of power, which will cater to almost a village or tens of villages. And most will be glowing, AC will be on, and other parking lights, everything will be on. But now the technology, satellite technology, using IoT sensors, you can sit in your place, maybe Mumbai or Delhi, still operate the buildings in Singapore and Malaysia. So this is the technology that is available, which we call it as digital twins or building information system, what we call it as, which will operate the infrastructure management. The slides are visible.
No, sir. Slide is not visible. You can reshare once.
So this is what I was telling, the building information technology and the digital twin is the new technology that people are adopting to map exactly the building, how it looks like, and they will connect with the sensors, and these sensors will be monitored from a distance place. And infrastructure. Today, infrastructure is going to become rule of the order of the day. because each and every project to monitor these projects using conventional methods. But the satellite and drone technology is being to monitor these things. Of course, agriculture, as I was telling, the agriculture, you take a soil moisture can be tested, can be identified using a satellite. Soil fertility can be put into the database system, and based on that fertility, sitting in Delhi, the people can tell the yield. And today, rains are expected to this extent. Groundwater is depleting. For a scarce water, what kind of, based on the fertility and available water, what is the best crop? So the agricultural revolution, you call it as smart agriculture. This is called smart agriculture. Based on the different IoT data and digital data and water availability, water prediction. One is surface water, another one is groundwater, another one is rainwater. Fortunately, all these three kinds of things can be monitored using the satellites, and still say that in this region, since the rain expectation is low, groundwater is going to deplete, surface water storage is also not that much. Let us go for less, let us say, water consumed crops. This is what exactly the smart agriculture, or you call it as whatever the thing that you call it as, that can be used. The space technology can be used to enable this one. Not only that one, let us say based on the agriculture prediction, you can assess what is the fertilizer requirement, and you can integrate with this one the supply chain, and you can say that, look, in Bihar, aloo is growing heavy, aloo requires this fertilizer. Wherever the fertilizer is there across the country, you please, there is a market, you please go and sell. You just see how the satellite technology is becoming a part of revenue. Forest is going to be a big what you call ecological balance, and this ecology balance, if you wanted to have proper rains and proper ecological balance, you have to maintain the forest is getting depleted on account of many things. Urbanization, they're cutting the forest and building the buildings. Forest fires, very prominent in some areas. And as per the Forest Reserve Institute, Forest Research Institute, I think somewhere I read around 400 crores we are losing every year. So when you can, using thermal imaging, you can identify when forest fire starts. You can tell the forest rescuers or forest officers, look, there's going to be a fire which may expand, please go and extinguish, so that ecology balance can be done. And forest cover index, when you are doing lots of national highways, what government is doing, they are encouraging the same people to regenerate the forests. This forest cover index is being maintained by a satellite, so that when you are going beautifully driving down the national highways, you will find lots of greenery on the other side and between. How? Is all because you are able to monitor the progress and penalize or encourage the contractors to develop the forests. So these are all the advantages of remote sensing. Up to that, remote sensing we have covered. Next, it comes to SATCOM. In the SATCOM, there are huge number of applications are there. Whether it is mobile connectivity, whatever the OTT platforms, cinema, serials that you are seeing across the globe. Earlier, when we were there, when we were kids, only 4 or 5 channels, Doordarshan channels used to come. Subsequently, maybe 20, 30, 40, 100. Now, sitting in India, you can watch any world's TV, Russian TV, USA TV, some kind of UAE TVs. How it is possible? Because of satellite technology. What you want, you are able to get it. This is the technology advancement. It is not only for civil. Let us say there is a beautiful district alert system, DAT, on the red kind of things. What you are seeing, it is a SATCOM come navigation application. When our fishermen go into the waters, many a times what happens, they will enter into international waters, national waters of other countries like Pakistan or Bangladesh or Sri Lanka. So the policemen, they will catch them and put them in bars, and this is becoming a nuisance for government also to get them back. Now this district alarm system, what it does, the moment based on the GPS positioning and communication, based on if they cross the boundaries, it will alert and tell the fishermen not to cross. That is why we are able to save the life of the fishermen. Okay, so many advantages are there. Let us say in-flight communication. Now that is the new thing that is coming, picking up. So when you are traveling in flight, you will not get the internet. Now using the satellite technology, you are able to get many of the the planes. Now they have implemented the internet connectivity, at least messaging system to start with. Then you can operate. The days to come, when the bandwidth increases, the technology improves, you will still work even while traveling from, let us say, India to USA. It may take 18 hours or 20 hours. You can still do your business. You can still do your meetings. The third technology, important technology, is navigation. And navigation you find in each and every day of life. If you wanted to locate your coordinates, you can just go to Google Maps or any maps, Bhuvan or any maps, you can find out. Let's say your asset is there somewhere in your village, you are not able to monitor. Somebody should not do and come there and dig it and take away the earth. If you still monitor sitting in your room, you can still monitor how your places are being protected, how your land is being protected. And if you wanted to go any place, you don't require any guide. Simply put the coordinates, you will go. You need not have to ask anybody. If you wanted to order it, or if you wanted to locate the trains, if you want to locate your buses, everywhere. And if you wanted to locate the traffic, these navigation systems are being used. So such a kind of satellite technology is helping us in our day-to-day life. Don't you think that you should know something more and start building your career towards that? Yes, you have to commit. You should know many more such kind of applications. What happens is, if you know the applications, then you will develop some kind of interest towards this technology and get to know. By the time you start building your passion towards the space technology, you will pursue career. And when it comes to you to professional, maybe after schooling, let's say intermediate, something like that, you will develop a passion to pursue that particular education, and that education will become a career for you to grow and become a self-entrepreneur, or otherwise some job, never mind, because many companies are developing all these things. The another important technology that is going to be is, many of you would have studied in your 8th class or 9th class, quantum physics, quantum technologies. Because this communication, you have seen the Operation Sindhur. When we are using our own communication network, somebody using a countermeasure to to block our internet and to track our signals and find out all our secrets. What for all these things are happening? Because the adversaries of the technology is basically the hacking. And many of the people, what had happened, their accounts were looted. The financial crimes are happening. All these things because technical sabotage is happening in the country, because they are also intelligence. Ultimately, we should go for a very secure technology that is called quantum technologies. Now, the quantum technologies are picking up very fast. And by the time you become graduates in another 4 or 5 or 6 years time, the quantum is going to occupy each and every brick of your day-to-day life. So it is very high time for you kids. What is quantum? How actually the quantum will work? Start understanding this one in a basic principles manner, and ultimately pursue your career in the quantum technologies. Okay, see, so far we have done, we have understood what the technologies are. ISRO, what government is giving us, what ISRO has given us. See, Mangalyaan, we have done it in first attempt. Such kind of deep technologies, it is not a joke. When we are unable to receive our own signal, phone signal, now today, how much we are suffering, you see. When a hotspot is not working properly, the entire discussion is getting hampered. You just imagine when some satellite has gone 60 crore kilometers away, if still we could find out the signal in the first instance and pick it up and started controlling the spacecraft, is it a small task? That is the technology our tech scientists have proven. Similarly, moon missions. Chandrayaan 1 has done wonders, identified water molecules. Chandrayaan 2 has completely mapped the moon, which is the highest treasury of the data. So with that data only, we could make the Chandrayaan 3 most successful. Chandrayaan 3, of course, you have seen it. That is the day we are remembering this year as a second year. The landing of Chandrayaan 3 and Aditya mission, because sun god is a god, is giving natural energy for us, but sun also sometimes become furious on us, and it releases coronal mass emissions, which are high energy proton particles, energy particles, which which affects our life, scientific life in the space. If you have satellites, they'll get affected. Some of the sensitive equipment in the earth, when ozone depletion is there, due to weak points, it will affect our magnetic field. So we should understand something is going to happen a couple of hours later, if we get an advance notice, so that we will protect our assets. So this Aditya mission, which was launched a couple of years last year or a couple of years back, which gives us an indication, look, there is going to be some kind of danger is going to happen, huge emissions are coming, please protect yourself. We are maintaining that kind of susceptibility also. So when we say ISRO, what is doing? ISRO is doing heavy kind of technologies development. We have nurtured the engines, we have nurtured the stages, we have nurtured the rocket production, and which are, most of you, I'm sure, you would have not even got an opportunity to go through these buildings where we are living day in day out. We have been living in these facilities in the sand dunes, in the seacoast, which is, the tower is 100 meters tall, just 1 kilometer from the seashore where rocket is assembled, and people will be sitting 24/7 and observing what is happening to the rocket launch, because that rocket takes the satellite into the sky safely, and the satellite will be there in the sky for 5 to 6 years, and that 5 to 6 years, huge amount of data it is giving to us to get benefited out of that data. And if you see, heavy radars, heavy antennas will be around the globe, and they will be watching the satellites 24/7. And if at all the satellite is coming back, it is going to be pushed into the orbit, so that the attitude and altitude controls will be there. And we are controlling all these things. The scientists, like soldiers who are watching who are guarding the, let's say, borders, the scientists are guarding these particular satellites, so that there's huge amount of data. You have seen the Sindoor, Operation Sindoor, how the satellite technology has played. We have not caused any harm to the civilians, but we have targeted. That's what GPS locations, GPS targets have been identified, loaded onto the seekers of the missiles, and our planes have fired the missiles exactly without harming much to the civilians. They have gone and hit the targets. How it is possible? Because we have space technology, the satellites above us is controlling these missiles, positioning and guiding. That is why they are hitting the target. They have hit the targets, and most of the things, the satellite technology, because there is a papers, open sources, data information is there. The American satellites have helped the Ukrainian people to locate the enemies locations. So these are all the advantages of the satellites. What is happening elsewhere, please get to know. This is only my intention of showing is, you probably would have not seen such kind of view graphs, how a satellite looks. Okay, this is a satellite, how it looks like. There is a reflector, there is an antenna. The black ones are called solar panels, which will give power to the entire, let's say, there are many systems, payload systems, control systems, communication systems. This solar panel will give power to the systems. The satellite will undergo number of tests before it is launched, because the adverse environment in the space have to be predicted and has to be put into the testing mode for the satellite. Because tomorrow, if the satellite goes up in the sky, when it is experiencing the adverse environments, still it should sustain. That is the reason several tests the satellite will undergo. Ultimately, it will be thermovac, that means sealed. This is called thermovac. It will be sealed before it is put into the rocket. These are all some of the view graphs. Okay. So what is next? So we have ISRO has got huge amount of approved programs. One is immediate program is Gaganyaan, then Chandrayaan 4, then Bharatiya Antariksha Station, then subsequently man on the moon. So for all these things, ISRO has to develop lots of technologies, lots of capabilities, and these programs will continue for next 15 years, maybe 10 to 2047, 2045, 2047. That means next 22 years. These 22 years, you are the people who have to shoulder all these responsibilities, and we will only start. Our generation is going to only start. And you are the guys who have to take all our dreams and all our seeds into a beautiful trees and fruits. So these are all the new technologies, reusable technologies. There, vertical takeoff and vertical landing, air breathing. So such kind of technologies ISRO is developing, and ultimately, yes, there is a huge responsibility on you people. You have to quickly complete your education, and during your education, even though you are studying 8th or 9th, this is the time we wish to catch up the talented people, motivating them and giving them the way. This is what the expectations of your parents or teachers or scientists or government. And ultimately, you have to dream what you have to do in the next 10 to 15 years to come. You have to qualify yourself. You have to dream. So just to brief on Chandrayaan, because many people ask, what is the Chandrayaan progress? Chandrayaan, we are in the successful. You have seen the Subhanshu's journey to ISS. He brought a lot of information so that the final Chandrayaan things, he may give lots of suggestions to the Chandrayaan mission for fine tuning, but we have almost completed, because it's not a joke to build a space suit or to build an environmental life support system or parachute to get back, or a pad abort test in case of any failures. The space module, creating a high pressurized and safe environment in the space against all radiations. All these technologies have been developed, proven, thousands of tests which you people would have not known. They have been undergoing inside the ISRO facilities, because we have to make sure when we have sent the astronaut, and we have to get back safely without any harm. And lots of you say missions are in a steady phase, or implementation phase, or approval phase. We have Sukrayaan, we have Mars continuation mission, we have Chandrayaan 4 sample return mission, expected to be followed by many more missions. Ultimately, a man on the moon is going to be there before our 100 years complete. These are the roadmaps, and he is responsible to receive those roadmaps or challenges or directions given by government of India, because ultimately they are the people who have to make the country and give the opportunities and budgets. Bharati Antariksha Station, already we have showcased the sample model of Bharati Antariksha Station 2 days back at Delhi. And this Bharati Antariksha Station is going to do lots of experiments, whether it is agricultural experiments, because in the microgravity, whatever the gestation period, let's say on an exaggeration scale, for doing some experiment, if it takes 10 days, if you go to microgravity, it may take less than 1 day. So the growth is multiplied. So you can carry out the experiments in a very particular procedure. You can bring back the earth and you can implement it. So this is the advantage of microgravity, especially organs. Let's say new organs are being made for improving the health of the humankind. New let us say medicines, let us say vaccines are going to be developed, because vaccine has to undergo testing for years. There is a COVID vaccine. COVID vaccine, when many people have done, they have to put it into the years. that years you cannot wait. So that's why when you take it to the space, that years will be may become months, and you will get the results. Okay, so I'm just exaggerating. I'm not giving just for getting a hope. So these are all experiments that are possible using microgravity in the Bharatiya Antariksha Station. You people again start developing, start searching today itself, from today onwards, what kind of experiments we could do. And in NASA, lots of documents are available. Like these are all the documents I've just downloaded. You can go through and see what kind of research happens in microbial research, or microgravity, or material science, or agriculture, or organ development, and physics. Okay. So these are all the new technologies that entire world is bubbling. When we are creating the technologies, on the contrary, there is a nuisance. When these debris means, let us say when a rocket goes up in the sky, the upper stages after releasing the satellite, they will be still roaming. And dead satellites, some satellites, most of the satellite, many of the satellites got dead. That means their fuel is over, and they are no longer useful for getting the data. So when active satellites are moving along with the dead, which doesn't have any control, because you cannot control the dead satellite. It may go here and there and hit the active satellites. So the monitoring of this debris is very important. So whenever our active satellite is coming near to the debris, what we do, we maneuver it. We call it as orbit maneuvers. Okay, and maneuver, when we do, it may displace from the correct position. Again, taking away, because it is not that when something in a traffic in a road, when a big stone is rolling, so you have to protect yourself. What do? You take directions. It is not that controlling the other one. You are changing a directions, and ultimately after the collision is avoided, you will get back into the situation. So this is becoming a big business, or big necessary evil. Okay, and debris removal. So those dead debris have to be brought down to the atmosphere and make them to get fired. So this is again becoming another technology to remove the debris. So this is another, let us say, technology to protect many number of satellites. See, yesterday I have seen a what do you call, public news. The Starlinks are going to launch another 30,000 satellites in the days to come, next generation satellites. Already 30 to 35,000 satellites are in orbit. So when such a kind of multiplication, and there is a projection every year, 2,800 satellites are going to be launched every year from henceforth for next 5 years to start with. After that, it may increase. So when such a kind of number, so huge numbers are being launched, we have to protect ourselves. That is why debris management is required. So ultimately, when it comes to the careers, yes, the careers you can pursue when you come to the any BTech people are there. You can apply for ICRB. One exam is there, which every year 2 times the ISRO conducts. You can apply for that one. Otherwise, there is going to be a campus selection when you go to the BTechs, and there going to be direct selection through advertisement in interviews. There are colleges like IAST, IARS, where certificate courses are being offered. You can get to know. Probably, I think those who are graduates are there. They can go through the website and get to know how actually they can get into. But never mind, ISRO will have limited intake. But there are n number of space industries are coming up, especially after the reforms. You would have seen rockets are being made by companies, satellites are being made by companies, applications are being made by a number of companies, revenues are huge. The computer science guys, the electronic guys, communication guys, instrumentation guys, material science guys, every engineering discipline person will find a place in the space domain. Nothing to worry. And if you say ISRO, to associate with ISRO, lots of institutes are there, centers ISRO has established across the country. You can get to know near to your place and get yourself, if a professors or somebody can help you, you will interact with them, you will try to understand what is happening, and you can invite those professors for a lecture. They will share what they are contributing to the space. But I feel the social responsibility is very important. That's what our Ashok Education Foundation is doing today. The space tutors, because it's not possible for ISRO people, maybe 5,000 to 6,000 or maximum 7,000 engineers. How many people they can come out and speak to you people? So that is why we have engaged a program space tutor where these space tutors will talk on ISRO, on space, will reach to you to the different corners of the country, and they will take the flag of ISRO. Not only that one, the technologies. You just see how many space tutors have been registered so far, and it is a continuous affair. Many people are joining the race every month. Okay, and there they have taken a voluntary kind of what you call oath, stating for promoting the space technology to you people. Please cooperate with them and invite them for such kind of special talks. And in addition to that one, there is if you go through ISRO website, there is a treasure of information is available. If you just open the ISRO STEM and Spark, if you just two icons I wish to give you, ISRO STEM and Spark. Please go through these two, and you find lots of information inside them. This will take you to a different sites, and you will have a beautiful information. You please explore these two sites so that you will get huge amount of information, videos, images, documents. Many things are there. And the other sites like Mosdak, Bhunidhi, Bhuvan, Vedas, all these things are basically gives you a glimpses of how there is a Mosdak is there. Mosdak, if you go, there is a picture even today at this moment how your cloud system, your climate is there. That information you will get it in that site. This is a public site where you can get to know the image of your Earth, on which the clouds and other let us say activities, cyclones kind of things, how they are on real-time basis, it is there. Okay, these are all the things I thought I will share with you whenever we do outreach programs. This is the footfall. Millions of people have been covered through our outreach programs, and still this particular STEM and interest have to be created amongst the students. Curiously, you have to develop your career towards STEM. I'm not telling space alone. Space means it's not rocket or satellite. It is everything. It is everything, right from agriculture to your water resources, or your waste process, waste management, or pollution. Every science is embedded as a part of the space. Okay. And once you develop this one, definitely I'm sure that we'll have a very comfortable life in future, and your life would be very productive and fruitful. That's all from my side. If at all any questions are there, I would be happy to answer.
Thank you, sir. We have students with their questions. So one by one, I will ask them to go ahead with the questions. Yes,
Okay.
you can come this side. You can ask this side.
Hello, sir.
Hi.
Good afternoon, sir.
Good
Myself,
afternoon.
and I wanted to ask you a question that what role do private space startups and the space ecosystem play in shaping ISRO's future collaborations? Means the private startups which are going on in space field and the space ecosystem currently. How does this impact ISRO's future collabs with other space agencies and these private startups?
See, the space tutors or space industry. See, today, if you see how many launches ISRO is able to do, maximum 4 to 5.
Okay.
Whereas today, if you just see the Honorable Prime Minister's speech, he wanted 50 launches a year. He has announced, he has given a direction for you people, not for us. So many kids are there, you people have to take that direction and start doing it. Is it possible for ISRO to do? Not possible. Then who will do? See, when Prime Minister of India tells, there is a meaning in that one, because he would have got a good amount of what you call inputs, that India can do 50 launches per year, and India has got a business to do 50 launches per year. Whether ISRO is able to do? No. So that is why the space companies and startups, new startups are coming first to take away the load from ISRO. And ISRO, like NASA, will be totally concentrating on the new technologies. See, Chandrayaan 4, industry will not do because industry requires revenue, profits, investments. And R&D, even though it is a part of the thing, but it is not only the job. When ISRO develops new technologies, materials which are having long gestation periods, when we develop, we will transfer the technologies to the industry so that the industry will go global and make the missions and do the revenue, do the commercial part of it, productionization part of it. So the Indian startups and one more angle for the Indian startups are innovation. Innovation means, let us say I develop a technology. The technology is either a bit obsolete or outdated, or let us say globally there is a better technology that is available. The innovation, what it brings is, it brings one more kind of layer to the existing technologies so that we can penetrate more. Because as a scientist, Indian scientist, I cannot go and discuss with other space agencies because it will become a secret, national secret. Whereas industries have got business tie-ups, they can go, they spend time in the elsewhere, they can understand many technologies like a collaboration, they can still do it. Okay, so these are all the advantages the space startups and space ecosystem can do wonders, and that is going to happen soon. We have already started. So far, not even a single satellite was built out of ISRO. Today, 31 satellites are building out of by the parties who are not in ISRO. Tomorrow, rockets going to fly. Applications, there is entire thing is being done by outside industry. Maybe you may not be aware, the industries like n number of industries today, Operation Sindoor is success because there are n number of startups who have mapped the entire thing and given the coordinates to the military to help them and to identify. This is called big data analysis, image processing, remote sensing, geo intelligence. Military, lots of military requires lots of intelligence, geo intelligence, electronic intelligence, then signal intelligence. All these startups are contributing in a very big way for protecting our marine resources, our earth's resources, our water resources, everything. So that is the greatest contribution. Please go through all these things, whatever words I have told. You Google it, lots of information is there, you get to know.
Thank you, sir.
Yes, next.
Good afternoon, sir.
Thank you.
I just wanted to ask, what
Good
subjects
afternoon.
we focus on if we wish to join ISRO in the future?
See, all subjects, there is no concession here. Every subject you have to read. Whatever you come across, you have to read and you have to excel. See, today you are in, let's say, 9th class or 10th class. You first read all your physics, chemistry, biology, zoology, botany, anything, math, everything. Okay, you are doing justice to that. When it comes to intermediate, if you choose MPC or BPC, everybody has got a role in ISRO. A biology student will have a role in organ development, a microbiology fellow will have vaccination, an agricultural fellow will have agricultural development, smart agriculture. There is no field left which doesn't take the leverage of space. You have to do all.
Thank you, sir.
Next.
Hello, sir. Good afternoon. Myself, Advik Vakede. I study in 6th standard. My question is, what advice would you give students who dream of becoming space scientists or working in ISRO?
First, whatever I told you, please go through these technologies or to the see how a mobile works using satellite. First, understand how when a car is going in the road, how that will be tracked. Because if you get a thing means it should be tracked. So when you start doing this kind of small projects, let us say you are from a village, let's say your dadi or your nani are in a village. In that village, 15 years back, how that village was, and now how the village is. You go through the maps, temporal maps are there. You go through the maps and identify how much your fields were encroached by your urbanization, how many fields were stopped crop making the cultivation, whether water resources, your water tanks are there nearby, how much whether they are there or not, they are there or they are vanished. First, try to understand your neighboring, let us say, ecosystem. Then you will come to know, अरे पापा पिताजी, अरे एक एक जो टैंक होता था इधर, अभी तो मेरा मैप में नहीं दिख रहा है, क्या हुआ? पूछ लो, पूछ लो. अरे एक कैनाल दिख रहा था इधर, ये तो अभी तो उड़ गया है कैनाल, कहाँ गया है, कौन लेके गया है, कौन चोरी किया है? वोट चोरी नहीं, ये तो रिसोर्सेस चोरी कौन करता है, पूछ लो. ठीक है, तभी तुमको पता चलेगा कि आप लोग आगे का दिन में क्या होगा. अभी पानी नहीं मिल रहा है, कहाँ से पानी आएगा तुम लोगों को? कौन सा नदी है तुम्हारा नजदीक में, वहां से आपको ड्रिंकिंग पानी मिलेगा? थोड़ा सोच लो, पूछ लो, अभी से पूछ लो, तभी तुम्हारा पास कोई नहीं आएगा, और जो भी आना चाहते हैं वो आंसर का साथ साथ ही आएंगे. ठीक है.
Next.
Good afternoon, sir. My name is Anay Kumar. I have a question for you. What qualities or skills are most important for becoming a successful space scientist?
I should say commitment and passion.
Yes.
ठीक है, मान लो पैशन नहीं है,
Thank
व्हाट यू विल डू, यू फर्स्ट गेट इनटू पैसा. पैसा कौन कौन देगा, ज्यादा पैसा अमेजन देगा या माइक्रोसॉफ्ट देगा, तो भाग जाओगे. ठीक है.
What did you do? What did you do to become a space scientist?
I just committed, that's all. जो करना है मैं करना चाहता हूँ. Because once you committed, commitment means, see, when what you are doing, you should start liking it. When you start liking it, you will become owner or you will become possessive. Possessive, ये मेरा घर का काम है जी. जैसा you just imagine, मान लो आपके घर में कुछ कुछ कंस्ट्रक्शन हो रहा है, कैसे तुम लोग इसको निभाएगा? एवरी मॉर्निंग तुम जाओगे और पानी है कि नहीं देखोगे, वेदर ऑल मैसन्स आया कि नहीं, मेटल है कि नहीं, कैसे कैसे तुमको दिखना, कैसा कौन सा पेंट लगाना, कौन सा मतलब प्लांट्स को ग्रो करना, ये सभी लोग देखते हैं ना आप लोग. क्यों? बिकॉज यू फील दैट इट इज योर हाउस. बट द सेम थिंग व्हेन यू स्टार्ट वर्किंग, इफ यू डेवलप द सेम अटैचमेंट, then it will become your house. Then it will not become a job. Then it will become your own what you call work. That is called passion. When you start developing the passion, the commitment will come. I don't mind working for 18 hours, 24 hours, 72 hours. We don't go even home when lunch comes. We sit in when I know even 12 o'clock midnight when a call comes, I used to take my personal vehicle, I used to go to site which is 25 kilometers away. If you start telling you go, if somebody tells you, your boss or somebody, then it will become a ritual. If you yourself think that I have to go, then it becomes you own that particular thing. So that is the passion the ISRO scientists have got. They won't be told. Nobody will tell, especially ISRO scientists. We take on our own and we take the responsibility and we go and we do the job as per the schedule. That is the passion of the ISRO scientists, what I have seen.
Thank you, sir.
Thank you.
Next.
Good afternoon, sir. Myself is Shanavi. And my question is, what are the unique technical challenges that are faced in lunar or interplanetary missions?
The interplanetary missions, the challenges are, see, one thing is we should know what is the environment. Better. Yes, sir. See, what is the environment that is there? See, when you are sending an article to an unknown place, if you know the place, then you can program it. See, every In the deep space missions, it is not that you are putting something program and with joystick you are controlling. Everything has to be pre-programmed. Everything logic and every algorithm has to be loaded. Before spacecraft is launched, this entire program, you have to load it. Okay, especially in the Chandrayaan, we do not know what is moon, because this is a precision data no country will share with us. Whether gravity is there, but what is the extent? If gravity is not there, however, the propulsion systems work. If whether, see, somebody were telling there is a huge amount of dust. When you land, ultimately that dust will raise, and couple of hours you cannot even open your sensors. That was the literature we have seen, we have studied, rather when we are making the mission. But when we have landed, within no time, we have opened the ramp and we made the rover to move it out, move it down. Where is the dust? See, these are all the practical things we assume, and we put the logic into the computer. Okay, when that particular thing is not, let us say, is not there practical. Let us say we have assumed that there is a dust, and we made to wait for, let us say, 2 hours or 3 hours. Okay, by the time the power goes off or the battery got discharged, what will happen? The machine will fail. So some of these such kind of uncertainties which are not known to us, these are all, everything is a challenge. The scientists have to go through thousands of papers, thousands of books and imagination. They have to assume that this would be there. Let us say a translunar injection is one activity. If the translunar injection, let us say if it has, the satellite has to go out of the Earth gravity, you have to fire a thruster. And it will go to the lunar trajectory and it will travel towards moon. And in the moon, again, when it reaches moon, you have to fire another thing so that it will get into the orbits of the moon. If you fire 1 second extra, or if you fire 1 second less, it will go into the deep space. That's all. कहाँ है spacecraft? भगवान जाने, खुदा को पूछना. ठीक है, तो इतना प्रेसिशन में ये कमांड्स रहता है का, that is the unknown things, lots of challenge. That's why Chandrayaan 2, what had happened, we could not predict many things. We do not know the terrain, we do not know many of the things, so that is why we could not finally succeed. When we have understood using Chandrayaan 2 orbiter the entire moon, the Chandrayaan 3 was damn success, whereas Japanese mission and USA private mission has failed. So this is the understanding what we should have.
Done.
Thank you, sir.
Thank you. Thanks a lot. Because
Uh,
no, I promise you 2 times I have changed. That's why I thought I should spend you sometime 10 minutes more. Thank you.
Thank you, sir. Thank you, sir. Thank you.
yeah, thank you, sir. I will just ask the advisory members, Apurva ma'am, Girish sir, Jayan sir, if they want to.
Yes,
Because I want to be brief because another meeting is pending. I request the other people to just be brief, if you don't mind.
Yes. So just
We
5
can
minutes.
have a detailed session later.
Yes, sir, definitely, sir.
They can be brief. They can be brief.
yes, sir. First of all, thank you very much for enlightening the students on your insights of various space missions of ISRO. We are extremely proud of you and your achievements, sir. And definitely, you can. We would like you to come down sometime to Nashik for a physical session and in-person session, maybe in the World Space Week, United Nations World Space Week, which we have been observing in Nashik for almost 8 to 10 years. Thank you, sir.
Very good. Very good. Thank you. Thanks a lot. I'll be happy. Let the Lord Shiva drag me towards Nashik.
Yes,
Definitely,
to
sir.
Trimbakeshwar. Yes, sir. Thank you so much.
Thank you. Thank you.
Sir, we have our vice principal, ma'am, Meenal Doshi, ma'am.
Hello. Yes, good afternoon, sir, and good afternoon, everyone. First of all, thank you so much for sharing all the details. And sir, I was very happy to understand from you. You had gone to students level to make them understand how it looks like and how are the details of it. I'm sure the students are benefited by this interaction with you. It was a lovely opportunity. And as Apurva ma'am very rightly said, we would be very happy to meet you in person with so much of energy, so much of knowledge, and would be waiting to see you in person. Yes, thank you
Thank
so
you.
much
Thank
once again. Yes,
you.
yes, sir. Yeah.
Yeah.
Good afternoon. On behalf of Ashoka Group of Schools, I sincerely thank Mr. Sudhir Kumar Ed for joining us today and sharing his valuable insights. Your words have not only enriched our knowledge but have also motivated our students to dream big and work with dedication. We are grateful for the time, wisdom, and encouragement you have given us through this interactive session. I also extend my thanks to our management, principal, vice principal, teachers, and students for their cooperation in making this event successful. Once again, thank you, sir.
Yeah, I would like to thank
Thank
all the advisory
you. Thank you.
members.
All of you for sparing in the afternoon. Thank you.
Yes, thank you so much, sir. Thank you.
Yeah, please go ahead.
Yes, sir.
Thank
Bye.
you.
Thank you.
Thank you. I
Thank you,
hope
ma'am.
I
Thank you,
can take
sir.
leave. Thank you. Bye.
Yes, sir. Thank you so much, sir. Thank you.